Assalamualaikum warahmatullahi wabarakatuh to our lecturer Dr. Muhammad Irman bin Ramli. Today our group would like to present about machine condition monitoring and fault diagnosis on shaft. Assalamualaikum warahmatullahi wabarakatuh to our lecturer Encik Irman. My name is Muhammad Faizwan bin Muhammad Fauzi and my metric number is B0717109294 and I am from section 1. Today I would like to present about machine condition monitoring and fault diagnosis on shaft. I will present about introduction and theory. So for the first part of slide, I would like to present about introduction. Okay, first point, the condition monitoring is the method of monitoring a condition parameter in machinery such as vibration, temperature, and etc. Usually, the condition monitoring help in assisting the operator or engineer about the root cause of faulty machine. The next point is condition monitoring to detect a significant change that is indicative of a fault in a progress. So, if the analysis spectrum show the symptom of faulty such as misalignment or unbalance, so the operator or engineer easily to planning the maintenance and decide what have to do to resolve the machine problem. For the third point, by measuring and analyzing the rotating machine vibration, significant faults such as mass unbalance, misalignment, and shaft bending can be defined and located. With the help of condition monitoring data, it is easy to identify which part need to be repaired or do a replacement without wasting a time. And for the last point in the first slide, it is machine condition monitoring and fault diagnosis is important for productive machine life, make the device reliable overall, reduce maintenance costs, and ensure consistency and desirability of product. Meaning that condition monitoring and fault diagnosis can help to maximize the maintenance and minimize the shutdown time and maintenance costs of the industry. Okay, for the next slide, we continue on introduction. The first point is problems in rotating machinery may also be caused by bearing degradation. However, reporting on the many different phenomena involved in bearing failure is beyond the scope. Bearing failure also affect the shaft performance and condition because bearing is the important part in minimize the force of shaft rotation when transmit the power to other part of machine. For the next point is there are several type of failure on shaft, as example misalignment, unbalance, and shaft bending. Okay, misalignment is the condition when the geometric center line of two coupled shafts not collinear along the rotation axis. For unbalance is the condition when the geometric center line of rotation axis doesn't coincide with the mass center line. And the last one is shaft bending is either by an axial asymmetry of the shaft or by external forces on the shaft producing the deformation. Okay, this is example of shaft failure. As we can see for the first picture, there is a shaft bending failure, and the second picture that is about a angular misalignment shaft failure. For the next slide, it is about introduction of FFT. Okay, first point is fast Fourier transform, as known as FFT spectrum, is an incredibly useful tool for machinery vibration analysis. As we can see, in industry, most machines have at least one shaft that will commonly face the issues of faulty. By help of this tool, it is easily to identify the shaft problem. Okay, for the next point is FFT spectra. Also, FFT spectra allows us to analyze the vibration amplitudes on the FFT spectrum at different component frequencies. And for the last point is FFT was calculated for vibration data that revealed that there would be at least one high frequency component every time the shaft rotating and pass through the subcritical speed zone. Okay, the vibration data is acquired through accelerometers were analyzed using FFT and power spectrum density. Okay, FFT was calculated for vibration data that revealed that there would be at least one high frequency component every time the shaft rotating and pass through the subcritical speed zone. This the picture of example of FFT. For the first, it about unbalance, and the second is misalignment. For the next slide is about theory condition monitoring. Okay, machine can be defined as an apparatus consisting of interrelated parts with separate functions, such as turbines, generators, pumps, motor, and compressor. It is used in the performance of some kind of work. For the next point is the process of monitoring conditions in machinery such as vibration and temperature to look for signs that a fault may be developing is the definition of condition monitoring. For the next point is condition monitoring is more efficient compared to reactive maintenance. Reactive maintenance meanings are repairs that are completed after equipment has already broken down. Okay, since faults can generally be avoided, hence reducing machine downtime, saving money, and prolonging the lifetime of machine. The condition monitoring is more effective compared to reactive maintenance because reactive maintenance will affect production time, increase the cost when shut down the machine, and high cost will affect to the